Okay, I would like to start with a very quick recap what we did last time about shallow copy. So let me just review very quickly by this diagram over here and tell you why it would be relevant to today's lecture. Okay, so we talk about the way you do shallow copy is by using the twin, right? And then what it does is simply just create a new object over here, and then that's for the first level. And for all the second level objects, there are aliasing. You can see this one is pointing to the same objects that's being pointed to by the original implementation, right? And similar for this one here, and similar for this one here. So there is certain things that's good about the shallow copy, because let's say this. Again, we are basically trying to compare two arrays. One is the imp, the other one is the shallow copy of the original imp, okay? In the case of the shallow copy, if you try to reassign at the first level, which means, for example, over here for the original array, I'm trying to reassign this particular slot of the array to a new string objects. In that case, we can easily tell imp and old imp, they are actually different, right? We can easily tell. So that means shallow copy does identify some difference at the first level. However, as soon as we go beyond the first level, for example, over here, if we do some second level change, which means rather than reassigning these pointers over here, we're basically trying to say we'll change the contents at the second level. In that case, let's have a look again. If you look at that imp and old imp, even though they are different pointers, right? However, you can see the objects that they are pointing to at the first position are the same. At the second position, they're also the same. At the third position, that's also the same. So in this case, if you do any changes beyond the first level, doing a shallow copy would not be good enough. Okay? I'm leading towards how to write a proper postcondition, so bear with me. Let's finish this series of examples here. But any question about what we have done so far is a recap. Basically, how you do the shallow copy. You only do the first level copy, but for the second level, it's all sharing. Okay, the third kind of copy there is going for one extreme. We're going to duplicate all the object structures. That's called deep copy. Okay, let's have a look very quickly. I'll show you this right away. Let me show you the code, how you should write it. So that's how you should write a deep copy. So for example, you would say old imp is assigned to imp.deepTwin. Whenever you say deep twin, things will be done recursively. So let me show you just on this diagram here very quickly. Okay. So let's say over here, first of all, we say imp is assigned to, old imp. Old imp is assigned to imp.deepTwin. That's what we are trying to do. Imp.deepTwin. So in this case, let's see what we can do. We follow basically the first step would be the same as the making a shallow copy. First of all, we have to say old imp being the deep copy, first of all, is going to point to a different array objects. Okay, let me just draw it this way. Let's put array over here. And then you will have 3 slots. Okay? Remember in the shallow copy case, we simply just copy the pointers. That's what we did. But now in the case of deep copy, we don't copy the pointers anymore. We have to recursively copy the objects starting from the second level. That's what you gotta do. Okay, let's draw it out. In this case, we have to recursively copy the string objects over here. I'll put S over here, and the value will be ln. So no sharing whatsoever. And then over here, we got also a string copy for the second string objects. The value is mark. And then finally, we have this, another string objects over here. The value will be Tom. Okay? Once we have done with these 3 objects over here, that's completely brand new. And then we assign them like that. Okay? Let's just do some check very quickly. First of all, if you do imp equals old imp, compare the references. We know that should be false. Very good. And let's see what the first level. If you say imp dot, let's say this. Imp at position 1 equals old imp at position 1. Used to be true, I believe, for the case of a shallow copy, right? Used to be true for the shallow copy. But now what about for the deep copy? Well, false, right? Let's see what we are trying to compare over here. Basically, when you say imp1, you're talking about this slot over here. You talk about this object over here. When you talk about old imp at position 1, this slot, you talk about this object here. They have nothing to do with each other, even though their contents are the same. So when I say content, that means let's do another comparison. Similar. So what I will do is I can say imp1 and then old imp1. If I use tilde, which I introduced you last time, right? It's going to do object comparison. In this case, we're not really comparing if they refer to the same objects in memory. We're just asking if they are of the same contents. In this case, yes. Okay, that's true. So that means after you have done the deep copy, the objects will be equal in terms of their contents, but there will be no sharing in terms of their addresses. Okay, that's a summary of what the deep copy is doing. Okay, so now let's try to think about if we try to make some changes to the original imp over there. And we'll do first level change. We'll also do second level change. In this case, can the old imp be affected at all? Okay, hopefully intuitively you can see from the diagram, no, but let's have a look. Okay, let me just remind you this block of code very quickly. So let's say, of course, the addresses will be different, so that'll be false. And we reassign the second slot to be Jim. So what we will do is over here, I can say second slot, rather than pointing to here, is going to point to a new string object over here, Jim. Okay? So now, in this case, if we try to run this block of code, would it work? Would it be true or false? So we are trying to say imp1 tilde old imp1 and imp2 tilde old imp2 and etc. We're trying to do position-wise comparison. Let's see one by one. In this case, let's see the first one. The first one here, you can see imp1 is referring to this object over here, right? Old imp1 is referring to this object here. Okay? They are the same. Don't you agree? You can see it's tilde comparison, right? Don't forget, it's tilde. Be careful if I put equal sign over there, it will be false. Be careful. Okay, you really got to pay attention to this. Okay, the content is the same. What about second iteration? Imp at position 2 would be this object here we just reassigned to. And old imp2 will be this object here. Are they of the same contents? No. That's where we get false, okay? And just talk about third iteration anyway. The third iteration is this object here versus this. It will be true, right? So which means eventually we'll get true, false, and true. Overall, it will be false, since we talk about for all, okay? All means for all, right? So you want to say every comparison we're doing there is true. Okay, let me just put it here. Basically, what we are putting there, let me put it here. What we just did, we say for all, let's say I is 1 until 3 in this case, okay? And then we say old imp I tilde imp I. You can think about the for all over here, as you learned from 1019, is a generalized conjunction, right? So this is really equivalent to the following. You would say, I'll say OI, okay, old imp at position 1, tilde imp at position 1, conjoined with, by using conjunction here, and you can say old imp at position 2, tilde imp 2, and also the third one, right? Nope. Oh, I just didn't write it. Okay, just old imp at position 3, tilde imp 3. Yeah, every comparison, every Boolean value should be true. As long as one of them is true, not true, overall it will be false, right? Okay, guys, any question until here? Well, you can think about, well, why would you compare mark and mark? Because remember, because imp 2 over here has been reassigned to Jin, right? So this is imp2 is not pointing to Mark anymore. It's pointing to this Jim, right? Be careful, all right? Questions? Line number 6. Just put single equal? Yes, if you put single equal, what's going to happen? If you put single equal here, I can tell you that, well, first of all, we should know what it is comparing. If you put single equal, that means you're comparing the references for every object, right? In this case, and conceptually, it's very easy. Is this the same object as this, address-wise? No, so that's false. The second one, is this the same, does this object have the same address as this one? No, false. How about this one, this? No, so false, false, and false. Okay, so again, be very careful what I put over there. Okay? Is equal is the same thing as tilde in this case, yes. Yeah. Mm-hmm. Okay, so now that's about the first level change. And so that means this part, deep equal, deep copy is the same as the shallow copy. Let's see the second level change that we did before. Okay? Over here, okay, that's about what we just said over here. Can you just have a quick look on the same block of code again, just up to line number 6. I'm going to draw that very quickly on the iPad, and then we'll see. Now I want you to picture how the copy is going to be made, and also how the object structure will be changed, if any change is going to happen. Okay, just give me another 10 seconds, and then we can first show the diagram of the deep twin, and then we'll see how the second level change is going to affect anything. Yeah. Well, check the slides. Tilde and is equal, in principle, they are the same, but there are subtle cases. You have to be careful. Okay, yeah, just check the slides. Yeah. Okay, good. Let's now go back to my iPad over here. I just need to draw the final arrow over here. First of all, would you agree this is what's going to happen if I say old imp is assigned to imp dot deep twin? Okay, no sharing at all. Agree? Okay, good. Now let's do second level change quickly. The second level change I would like to do is to say imp at position 2 dot append. Imp at position 2 is referring to this position over here. So the address is talking about this object over here. And I would say append 3 stars to there. That means I'll change this mark into mark star star star. Okay? Now, if we go back to the original check over here, remember in the case of shallow copy, the shallow copy cannot tell. Because in the case of the shallow copy over here, sorry. Okay, didn't see that, okay. In the case of the shallow copy, let me just remind you here, in the case of shallow, this is shallow copy. At the second level, they're simply just sharing the same string objects, right? That's in the shallow copy. But in the deep copy case, they are not sharing. So now, if I run the loop, let's see one by one. Imp 1 and old imp 1. Okay, let me just highlight them. Imp 1 is this object here. Old imp 1 is this object here. Are their contents the same? Yes, right? Contents, tell them, right? It's true. And let's say imp 2 over here, which is mark star star star. And also old imp at position 2 is the original mark, which was unaffected. There was no sharing. In this case, true or false? False. True, false. And the third one, referring to this one and referring to this one. So comparison for contents will be true. So true, false, and true for universal quantification will be false. That's why. So now these, so far we actually consider 5 different cases for the 3 kinds of copies. So these will lay out the technical foundation for writing complete postcondition. Okay, we'll definitely see similar idea once more, but repetition is nice. Okay, so any questions about this before I move on? We're good. Okay, Okay, you'll see why we are doing this. It's worth the time. Yes. Uh-huh. You can definitely do deep twin and twin in the post condition, but you have to be able to judge. Okay, let me tell you the conclusion right away. To be 100% safe, you should always use deep twin to be safe. You should want to make sure there's no sharing. Okay. However, there will be some cases you can get by without using deep twin. Maybe shallow copy will be enough. So in the test or in the exam, I would like to see if you can really see why we should really use deep twin but not twin. Right? So that's the difference. That's why we're going to have the discussion here. Yes? Yeah. What do you mean something else false? So that's, oh yeah, this part is true, right? Because they are of the same contents, right? Yeah. But you can see the second one, we are talking about this, which is modified to mark star star star. That's not the same. So we got true, false, and true. Yeah, altogether it's false. Yeah, universal quantification, yes. Okay, good. Let's go back to the slides, and then let's do over here. So now, I would like to talk about, again, just how the contracts are checked at runtime. What we did before was just present you the state diagram. Now today, I want to focus more on how to check post-condition. It's really important, because somehow this is done automatically for you in IFO. So you have to somehow understand how things are working automatically. Of course, if you do it in Java, you have to make sure you implement your post-condition checking exactly like this. There's no way around. That's how you check it. Okay? So now let's see how, I'll just go through some slides, and there will be some interesting comparison to make. And this will also be useful to your lab. I'll draw some connection a little bit later. Okay, all the contracts should be Boolean expressions. And now let's talk about feature call. Let's say you got an account object ACC and say withdraw 10. So before we try to make this feature call, of course, we have to check for precondition, right? And of course, you have to, we say that it's called the pre-states before you try to execute the implementation. And now, over here, you can evaluate the precondition quite easily. Whatever the current state is, the pre-state is, just use those values to evaluate. So precondition check is trivial. It's not easy. It's not difficult to implement. The post-condition is tricky. Okay? Now, I want you to get this line very straight, and then I'll use an example to emphasize your understanding. So now, you can only use the O keyword in the post-condition. That's a constraint. You can only use it. So why can you not use the O keyword in the precondition? Well, because the values over there are old anyway, so you don't have to emphasize that. Okay, that's why you cannot use it. Okay. So now, when I talk about cache values, which means at the point once your feature body is executed, you want to compare the pre-state value and the post-state values. That's why you have to store the pre-state values beforehand in order to do comparison. And the way IFO does it is kind of depending on you, how you write the post-condition. Okay, the principle is very easy. Let me just read this to you. Whatever old expressions you write in the post-condition, IFO will simply do a simple assignments for you to store that value. Now imagine this. For example, if I say old, current is like this in Java, right? If I say old current in the post-condition, what would it do before the feature is executed? You would say something is assigned to current. It's like reference copy. Agree? If I say in the post-condition current.twin instead, what would be cached? You would say something is assigned to current.twin before the feature is executed, so that will be a shallow copy. Okay, so you can kind of see the difference. But let's do some practice. I got a series of examples for you. Okay, let's switch to iPad to get an idea. Let's imagine you got this many. Let's do the first one. First one is kind of unrelated to the rest. Let's do the first one very quickly. So now the most critical thing for you to judge is what exactly is the expression that's being owed. Okay, you got to judge. Okay, let me just do the first one very quickly. The first one over here, you can see that we say O balance is equal to, O balance equals balance minus A. In this case, old goes together with balance. Okay, so that means the balance value will be cached beforehand. You can imagine that there will be a corresponding assignment under the hood by the iPhone. Okay, so how to cache? So let's say we have a naming convention where I simply say old underscore balance. Okay, just some variable that we named them. And then it's simply assigned, just simple assignments. It's assigned to balance. So that later on in the post condition, if we want to evaluate, how would they evaluate? They will simply say old balance equals balance minus A. That's how they evaluate it in the post condition. So this is the cash value. This is the current value after the withdrawal has occurred, and also minus the parameter. Okay. Does it make sense for everybody? If it doesn't make sense, please say it now. Okay, yes. By cache. Oh, cache means to store. Yeah. Maybe I shouldn't use cache. Cache is more like a database term. You cache the value somewhere so you can just get access to that very quickly. Yeah.
Professor, the old keyword doesn't come across until you go into the post condition, right?
Yeah.
So for example, if you're actually like changing the balance value in the implementation, in the do block,
Yeah.
what happens when when you actually change the balance and then you come to the post condition?
Let me make this absolutely clear because it's really important. Let me just go for this. Okay, let's say this. Okay, imagine that, let's say we have one object state and the other object states. And what we are doing over here is by doing, let's say, ACC dot withdraw. Let's say 10. Let's say in the pre-states, balance is simply just 100, let's say. Okay? And let's say in the post condition over there, we say ensure balance equals old balance minus old balance minus 10. I'll just replace A by 10. Okay, that's a post condition. Agree? Okay, the blue one is basically what you have known so far. Now I'm going to put the green one, which is what IFA will do for you automatically. IFA will look at your post condition over here, decides that when you say old should go together with balance over here. So that means they should cache they should store the value of balance before the feature execution. That means in the pre-states, they will also try to declare some variable over here, old balance. Okay, you can see the underscore over here, right? It's a valid variable name. It's assigned to just balance. Okay, and let me just finish this. Okay, and then after the execution of this, okay. Oh, by the way, what would be the value for old balance over here? 100, right? Okay, and then after the execution of ACC that withdraw, what should be the value for balance over here? It just changed, right? You can see the way we change it, balance here has nothing to do with old balance anymore. They're completely separate copies of values. And now, how does IFA evaluate this expression over here? They will simply do balance, which is the current value of the balance after the change, equals old balance over here is the variable which we assign before the execution. Minus 10. In this case, what do we get? Balance is currently 100, right? Sorry, 90. And then old balance was exactly what we cached before, which is 100 minus 10. Is that true or false? True. Okay, it's a simple case how we store the value beforehand and then check it. Does it make sense to you? Okay, you will do the same thing for Java. Yes, question.
So the only thing that gets stored is the thing with the old object.
Exactly. So the only, well, let me just repeat what you just said. You said the only thing that will get stored is whatever that counts with the old. But you have to decide that whatever it is. The whatever is kind of hard to decide. Okay, I'm going to show you how you can decide it. Yeah.
This is very, if you use the ensure then keyword, this wouldn't work, right?
When you say ensure then, let's delay that discussion. When you say ensure then, we are talking about inheritance. Let's delay that topic. Okay, yeah, just ensure for now. Okay, guys, any questions? Any confusion here? Yes.
What if we use old balance dot twin?
Old balance dot twin. First of all, I don't think you can do it because balance is of integer type. I think you can only do twin for reference type. But in this case, when you say, okay, how about this? We'll see more example. You will see exactly, you will see the answer to your question. When you put twin or deep twin, yes.
So if we don't have the old keyword, so the IFA wouldn't cache the value before the method?
Correct. So the remark was, what if we get rid of the old keyword over here, hypothetically? If we got rid of it, that means no caching will be done in this case. right? So the old keyword give an indication to IFO what expression value you should really cache before that. Okay, let's see more example. Okay, we're done with this one here. Okay, I want you to, first of all, before you think about what the corresponding right column should be, can you look at 1, 2, 3, 4? And by the way, current is just like this in Java, right? You know that in Java, if you say, for example, if I say accounts at position I, let's say account is an attribute for the current class, .id. Implicitly, that means this dot. So the same idea. Implicitly, it's like a current dot. Okay. Try to look at the 4 rows over there. There is a reason why I arrange them in this way. And pay special attention to how I parenthesize them. Okay? Okay, so now, let me ask you this. First of all, let's make a decision for each one of them. For the first case, what about the last case? That's easier. What's the expression that's old? How do you know that's current? Well, you can see the parentheses over here, right? So it tells me only the current should be old. Okay, agree? What about the second last? Let's go backwards. Accounts over here, right? You can see the parentheses over here. So only the accounts is old. So we're caching a little bit more. We're caching a little bit less, I should say, right? For this case over here, we are trying to cache the value for current. And over here, we are trying to cache the value for current accounts. What about the second, third? What are we caching here? Well, we're basically doing the object that's being pointed to by account at position I. Okay? What about this one here? Whole thing, right? Just the ID. You can see the difference here? Okay? Basically, I don't need to write it down because it's on the slides. Okay? Pretty much like that. So why is this crucial? I will show you one direct correspondence to your lab in just a moment. It's really important. But first of all, any question about this? Because the way you parenthesize the old expression will affect how IFO will decide to cache the values at the runtime before the feature is executed. That's the main point. Yes, well, 3 questions. Okay, start with you.
What's the difference between the last one and the second last?
The last and second last. Let's go back to iPad here. You can see the last one over here. Oh, I see. Okay, thinking this way. For the second last one, maybe it'll be better. You can think about we're just referring to the accounts over here, right? Implicitly, current is there. It's like in Java, implicitly, this is there. So you can think about this one is really equivalent to current dot account, right? And then you can see the way we put the parentheses over here, we're saying that old only covers current accounts. Okay, yes?
Current accounts and ID.
Current, which one?
Current is like this, right?
Current, well, you can think about current as the current class. Let's say we are now in the class of bank. That's why we got an attribute called accounts, right? So current is like we copy the bank objects. Okay?
Saying that you have this current object of a bank.
And then simply make a, okay, how about this? And now, let's say, let me just go a little bit further. Let's say the current class is actually the bank class. Okay, let me put 3 more for you. Okay, let's see what's the difference. If I simply put, let me just erase this part here. Okay. If I put number 1, if I just put current versus, okay, old current, that's what I meant to say. And also old current dot twin versus old current dot deep twin. 1, 2, and 3. Let's say somehow I decided that these are the 3 old expressions. So how is IFO going to cache them differently? What about for the first one? Well, for the first one, thinking this way, first of all, before the feature execution, IFO is going to say old current, like a variable name, is assigned to exactly this expression here, right? Current. Isn't that reference copy? Okay? Second one, I can say old current twin is assigned to current dot twin. That means the caching will do a little bit more work. It's doing a shallow copy. Versus the third one here, old current deep twin is assigned to current dot deep twin. Okay, I'll just say DT, okay, deep twin. Right, you can see the three different cases. That means if you put deep twin in your postcondition, it's guaranteed they will make a deep copy for you for the corresponding expression. And this is completely relevant to how we write the postconditions. Yeah?
Which one does the caching do automatically? Do you have to specify what sort of things it caches?
Well, the way you put the O expression is going to decide how they cache it, right? For example, over here, again, if you look at, let's say over here, the way you put for number, this one here, versus the way you put for this one here is different, right? Because here you brackets around over here. You brackets around here, so that means you're going to cache accounts I, right? And over here, since you brackets until here, so you only cache accounts. It's up to how you specify the contracts. Yeah, so the way you specify the O expression in the postcondition would affect how the O value is cached, okay? And the caching process is completely automatic, but you have to know how it does, okay? Any questions? Yes? Yeah, you can first, yeah, and then him.
Okay. In Ensure,
Mm-hmm.
we're only allowed to use old, current, and like to get what we want, right? We cannot use the object that we created in the body of the method, right?
Oh, okay. So yeah, you're right. So basically, in the postcondition, you can only refer to attributes or the old version of the attributes. But okay, let me tell you what you cannot use in the postcondition. You cannot use local variables. You cannot, yeah, basically you cannot use local variables.
Why?
Because local variables are part of the implementation. They should be hidden from the contracts that's exposed to the clients. Okay, that's why. Yeah, question?
Also on the right hand side, when you said how to cache all balance is equal to balance,
Mm-hmm.
that balance is before the row.
That's before, yeah. Yeah, as you can see, the question was, let's look at the first row over there. When I said all balance is assigned to balance. So that caching process was carried out exactly over here, right? Right before the execution of the feature, right? Just refer to that diagram there. Okay? Any more questions about this? Yes?
So is it like to maintain like the pre and post?
Exactly. So, yeah, the entire purpose of doing this is to make sure you got the values for the pre-states, you got the values for the post-states. That's the thing. That's the main reason. And why do you need pre and post states? That's how you draw the connection between them to make the post condition, right?
If you don't have the old, then it's just like the post. And then
Yeah, exactly. Yeah.
be violated.
Exactly. Yeah. If you only got the post state values, you cannot write very expressive post conditions. Yeah. Yeah. Any questions? Yeah. Before we get to another example.
Well, for lab one, it says
I'll get to lab one in just a moment. Okay. Okay. Any questions? Yeah.
So the last thing you drew with the ID
Mm-hmm.
and the other,
Okay.
ID had features that they also cache.
So ID here, okay. Basically, whatever you put over here will be, well, you're saying if ID is a string, right? So for example, if I say, let me just go a little bit further. Maybe what you meant to say was something like this. Let's say I got another version here. Let's say, can I just put another version here? I say old, and then I say accounts I dot ID at position. I forgot exactly what the feature is, but let's say for the string, you support something called item, right? You want to go to which character? I want to go to maybe the second character. If that's something what you say, that means it's only going to cache this expression over here, right? It is not going to cache the entire string. It's going to cache just the second character of the string. So completely depends on how you write the O expression.
Well, what if, let's say, accounts I had a feature called owner, and owner is some sort of composition, or
No, you know what? It doesn't matter what the object actually contains. It's really up to what you say over here, right? So over here you can see I only say accounts I.id. So only the ID will be cached, only that value there.
So you have to, so if you're going to use the old expression and you want to get out, okay, I see.
Okay? Right. Guys, it's okay to ask questions because it's really important to understand this. Okay? Go ahead.
One question.
Yeah.
Is there any downside to just always doing a deep?
Good question. Is there any downside of doing a deep twin always? The downside is it's very, very inefficient. You're basically recursively copying the structure for whatever object you're copying, right? However, remember, we only do this in the contracts. And contracts are only for your design purpose. Eventually, they will be turned off when you release the product, so that's okay. It is okay to trade a little bit inefficiency for correctness of your design at the design phase. Okay? Question, yeah. No, you cannot. The question was, can you use the old keyword in the do and block? The answer is no. You got do here, and then let's say this is ensure. No, you cannot use old keyword here. No. The only place you can use old is in the post condition. However, let me now go to no further question, right? Let me show you something that's related. This may be some errors many of you have seen so far. Okay, let's have a look together. So this will be appropriate time to talk about it. I think you're ready to judge. Can we have a look at this simple class over here? That's where it's zoom in? Yeah, sorry, it's a bit small, right? Is it okay? Is it visible? Okay, I'll read it to you. We have a class called linear container. And then we have a feature attributes A of type array of string. We have the count feature, which tells us how many items are there in the array. And also we got get at a position, at a particular position, right, for the string. And then we also got a constructor, right? Okay, now, consider the update feature over here. We want to let's not worry about the precondition, okay, just for simplicity. Of course, you should put precondition, but let's simplify that. For updates, I want to update a particular position I to be of value V, okay? And now, look at the post condition over here. Basically, what I'm trying to say is I'm going to go across from 1, starting with index 1, to the size of the array, as j as a cursor to integer. I say j.item not equal to I implies the old value that I get on j is equal to the new value at position j. Right? Logically speaking, I can tell you that's correct. Basically, I'm saying that for any item that's not supposed to be changed, to remain the same. The old version and the new version are the same. So now, can anybody see if there's anything wrong with this post condition here? Would it even compile? For those of you who have seen that, you might have, maybe you didn't ask me, or you didn't ask me, I said, wait for today, right? Anyway, it wouldn't compile. Okay, but let's be logical over here. Okay, since now that I think we are now ready, be very careful. Let's be logical here. Based on what we're writing over here, I want you to focus on this line particularly. This line here. Could you please look at this line only? J.item, this line here. Okay? That's the only line where we got the old keyword. Okay? And now tell me, based on what we have learned just 2 minutes ago, in this case, which expression value will be cached at the runtime before we try to execute this feature here? Which expression value? Okay? Get j.item, right? Okay, well, it's quite obvious, right? Also green it, so hopefully you also see the hints over there. Okay? Okay, that's exactly correct. So that means the way we write the old expression over there tells us we're going to get, the old expression is only associated with get j.item. So which means we're going to cache this value. Okay, now let's do exactly what we said before. So that means I for runtime is going to say some variable name is assigned to get j.item before this feature is executed. What's the problem there? Is j known there? You see, guys, you see what I mean here? So let me just make it more explicit over here. Let me reuse this diagram here. So what it will do is something like this. It will say something like, let's say old, let me be precise, old, and then get J item. A variable name is assigned to get, it's a feature call, J.item. Okay, this will be executed right before the feature is executed. Right, okay, so now the issue really is, what's really J at this point here? What's J? J is actually a variable that only makes sense within this across that we introduced as a J, right? So that means J doesn't even exist at that point, under the hood. So that means, so this, what lesson do we learn? Lesson we learned here is you should never try to involve a local variable, especially in this case over here, like a J, a cursor variable, as part of the O expression. Right? Because the way we put it over here, we're saying that old is associated with an expression get J.item. It involves J, but J doesn't even exist before the feature is executed. Make sense? Okay, now, yeah. Which statement?
I understand the fact that you can't use them locally because it's bad, but I still don't get the conceptual idea.
Conceptual idea is, first of all, do you get the idea that over here, based on how we write the old expression over here, the green one, get J.item, will be cached. Right? Good. So that means this is how we're going to do it. We're going to say something like this before the feature is executed. Some variable over here and say get J.item. But J doesn't really exist at that point. J only exists in the scope of this across loop over here in the post condition. At that point, we don't know what J is.
Or if it was the case that it was actually involved in not the post-condition, but the actual implementation, then it would be fine to use it as post-condition.
No, we cannot, well, as I said before, you cannot use local variables in the post condition, right? So this J over here is basically just temporarily introduced by the across as a cursor, right? So that's why we can use it. However, if you got, let's say, right before the do over there, you say local and any variables over there, you cannot use them in the post conditions.
But it is able to use attributes that define.
Yeah, that's fine. Any questions? Yes. Guys, could you please? Yeah, could you please? Yeah, I know it's interesting, but you can just ask me a question, okay? One person talking at a time. Yes.
Would another accurate way of saying this be that the old operator does not automatically allocate an array for us? Because what we need is an array to put. If we wanted to do it this way, we would have to make an array to put all of the.
So basically, what I'm trying to say over here, so we are the ones who actually write the post condition. Depending on how we write it, IFO is going to store the value before this, store the pre-state value differently. That's my point. Of course, it depends on how you write it. Apparently, the way we write it over here wouldn't make sense because you cannot cache it like that. J.item simply doesn't exist in the pre-states.
I figured out a better way of saying what I'm trying to say. Old only caches one thing for us.
What do you mean only one thing for us?
It only makes one pointer. Like it only makes one.
Well, the way we cache each old expression, is by a single assignment, right? So the right-hand side, well, of course, because each assignment can only do one assignment, right? So now the right-hand side of the assignment, IFO does not decide how it should be written. It's us, the developer, who decide how to write it. Now, you shouldn't say variable, you should say expression. Some expression is cached. Okay, so now let's try to understand this a bit further. How can we fix it so that it means something conceptually the same? Okay? Dawood, you want to say?
Should you be caching A then?
Caching A? No? Okay, let's say that's why I wrote it like this. I don't want to see any implementation attributes. Okay? I can tell you that you can do something very similar to this. It's just that you have to cache something that wouldn't involve any J, any cursor variable. That's something I want you to try. Why would you have result? This is not even returning anything, right? Yeah. The question is, the answer, to fix this, the answer is rather easy, okay? You just have to think about implicitly what does sorry, let me say it again. Implicitly, what does get j.item really is? It's current dot get j.item, right? So now, can we just rewrite it slightly differently so we only cache the part that does not involve any cursor variable j? Is it possible? You just switch?
So instead of j.item, the first one,
Mm-hmm.
we switch it to get j.item?
No, not really. Yeah, j.item should still be there. It's just we have to somehow group the old expression a little bit differently.
So in this case, using j item should be fine because j is within the post condition.
J should be within a post condition in this case, yes.
This is fine to use j item.
Yeah, it's fine. But I'm just saying that the way you write this is going to not to make the caching work.
Can I try? So there's a loop that doesn't require for you to use a counter, doesn't it?
Well, don't even think about the counter. I want to keep the counter. I like J. I want to keep J there. Okay? I'm stubborn. I want the J to be there. Okay?
Do get j dot old item.
Can I just ask you to move because I definitely can't see him?
We do a j dot old item, like put the old in.
Well, if you say, well, what the suggestion was, if you simply say get old j.item, right?
No, get j dot old item.
No, it doesn't make sense. Okay, how about I show you the answer? If more questions. Well, yes. Old current, yes. However, okay, good question. I think that you're getting there. Okay, maybe that's something you're thinking about. Let me just write down what you might be thinking and tell me if that's exactly what you're thinking. Okay, let's see. So you say yes even before I wrote it, right? Old current dot get j dot item. Is that what you meant? Ah, I like it. You got some intuition here. Why would this not work? Well, in this case, you're basically the same as before, right? Because in this case, what's the expression being owed? Current dot get j dot item. It's still that entire expression. You want to isolate the current. So you gotta force the compiler to believe. Bracket like this. That's the trick. And of course, there will be some further decision for you to make. This will compile, but to really make it correct, you have some further decision to say whether you should say old current dot twin versus old current dot deep twin. So that's some further decision I have to make after we talk about another example. Okay? Okay, that's how you fix it. Hopefully that might help your lab 1. Some of you may already have seen something like this. Okay? Any questions about this? Clear? Okay? It's not very straightforward, so you really have to make sure you understand the big picture. Yes?
So if there was like an array inside current, would the references inside the array also be cached?
Oh, you tell me. You tell me. The question was, you got to tell me. Let's try to test this together. Let's say this is the new expression I wrote. The question was, again, how the caching is going to be done, right? If I say expression like this with the brackets, okay? We know that this is what's going to be cached, right? How do we do that? We will have in the pre-state some assignment like this. We'll say old current is assigned to just this expression over here, right? Which is current. And now in this case, what do we copy here? Just the address is a reference copy, right? On the other hand, if we said old current twin inside the brackets, in that case, we'll make a shallow copy, right? If inside the bracket we say old current deep twin, then we'll make a deep copy to cache. Okay? So the main point is how you write the old expression, how you bracket that, is going to affect how things will work at the runtime. So if you got a, well, let me ask you this. If I, very simple analogy, 2 plus 3 multiplied by 4. What is that?
14.
Oh, good, good. You guys are really talking, that's good. 14, right? What if I wanted to work the other way? I want it to be 20. Put brackets, exactly. Without the brackets over here, the way compiler will understand this expression here is to say after the old, this whole thing should be cached. If I want a compiler to believe it should be only the current part that should be cached, I put the brackets. Think about it. Yes.
So now when we have brackets, it's
Yeah.
now what is cached?
Only the current, the reference to the current. Yeah, so again, so if I say all current inside the brackets, what's going to happen at the runtime is something like this. You will say all current is assigned to current, right? Because current is the expression that will be cached. So that's why we simply say current at the right-hand side. And then just do a reference copy in this case. Okay, are we good? Yes, question? Yes.
So caveats that we have for the old keyword are just the same for the current keyword.
Sorry, say that again. I don't quite catch your question.
So the caveats that we have for the old keyword is just the same for the current keyword?
No. So what's the caveat I had for old? I actually had it in the slides. Why don't we have a look at them together? So it's a compiler time error. The logic reasoning I already explained. So this is something you have to bear in mind. The idea is the old expression, whatever old expression you put in the post condition, they should not involve the local cursor variable. That's the caveat. Okay? If you really want to isolate the part without the cursor variable, use brackets. Okay. Yes.
Just a reference copy, isn't that still worthless?
Oh yeah. So the question is this reference copy really useful? That's another decision we have to make. Should we put current.twin or current.deepTwin? I can tell you the conclusion right away. To be safe, you should always put brackets old current.deepTwin. But the reason is what I explained. The reason I need to just go through one more example in complete details. But I think we only got about maybe 25 minutes. I think let me skip that example just for now. I'll move that to the beginning of Tuesday. What I will do now, I will show you how you can write tests for contracts. That might be more relevant to your lab. Okay? But before I go there, any questions about this before I change the topic? Yes.
So I had a problem with the lab before.
Mm-hmm.
I was trying to compare the result and the insure.
You know what? If that's very specific, how about we talk about this after?
No, just I want to say that sometimes like the old is equal actually to the current, right? I had this problem.
How about this? Explain your problem to me, and then maybe I'll share that with everybody next time. I'll put it in a better way.
Okay.
Okay, how about that? Okay, that'll be better. Okay, any questions about this whole topic? Yes? So in the post condition, you definitely cannot put any local variables you declare for implementation. Also, you should not put any implementation attributes like what you were forbidden for lab 1. So these are the two constraints. And also be careful whenever you talk about old expression, make sure it does not involve any cursor, like the way we explained. Okay? So guys, the topic is actually not very easy, so please do spend some time, reiterate the video if necessary. You can ask me later if you want. Okay, let me just skip the top. Basically what I originally planned to do was to go through a lecture, another example about how we can use deepTwin and etc. But you can take my word for this just for lab 1. Whenever you're wondering about for the old, should I put old current.twin or old current.deepTwin, you can always put deepTwin. But for the reason I will explain to you on Tuesday. Okay? Good. So now let's talk about how you can write tests. Okay? Let's now do another new lecture here. Especially, I think there are 3 kinds of tests you can write. And then let me just show you the slides, and then we'll go through them all together. The one that needs a little bit more explanation is how you write the test for post condition. That's the one that's interesting. And for that one, I will show you a design for doing the test, okay, by showing some architecture. That was the most interesting one. Okay, let's just go through some basics. Okay, let's, for the discussion here, remember this class over here that we talked about in the first 2 lectures, account. Let me remind you very quickly. We got account class and we have constructor make. And we're going to focus on the withdraw feature command. And remember the precondition we got, non-negative amount should be larger than 0. And also the ensure clause, balance deduce. Remember these are the tags, right, for the postcondition for tags, T-A-G, tags for traceability. And then it's balance equals O balance minus amount. And also we got invariance. Okay, so this is how we're going to play with our example here. Okay, so now there's a contract view, okay, the same as before, okay. Let me go directly to the test cases, okay, and then for some other kind of concept, maybe I will explain them next time. Let me just make sure I really can cover how to write the 3 kinds of test cases, okay. How about this? Let me just explain this diagram very quickly, okay. We talk about test-driven developments. Okay, TDD. What does test-driven developments means? Basically, it simply means you should always start writing your test cases maybe even before your code is completed. Basically, as soon as your code becomes executable, you should start writing the test. I'll give you one very simple example. We all know about stack, right? I'll give you one example. Yeah, executable means the compiler is happy, so you can somehow execute it. That's what I meant. Okay. Let me just go directly to this example I want to show you. Okay, I'll go through these concepts maybe next time. Okay, I want to save time today. Okay, first of all, let's read this. You want to start writing test cases as soon as your code becomes executable. So now, when I say executable, maybe you have already finished one unit, like one feature already. Or even before that, if you only got a header of your feature, even that, you can start writing test cases. You might be wondering for what? The answer is documentation, and clarify your understanding. I'll give you one example here. Let's say I'm doing the stack implementation, right? We all know about stack. Let's have a look at here. We got a class called stack. The G over there is generic parameter, which we'll go through very quickly, go through very soon, next week. And then you can see here, I have no implementation attributes just yet. I didn't say whether I'm going to use a linked list, array, or whatever. Okay? And then in the top over there, query, I didn't say whether that should be an attribute or should it be a query. I didn't say it. I just put a header over there. Oh, actually, sorry, I did say that. You can see that over here, I have do and end. So the implementation part is completely empty, nothing there. And also for making an empty stack supposedly also is empty, does nothing. For push and for pop, just the same. But this class will compile. They will, even though I didn't do anything yet. It will compile. So now I can already start writing tests. It's recommended you do it. Okay? How can I write a test? Right? So basically, the way you write a test is not so specific to the coding details for your features. You want to treat it as a documentation of how the features should work together. Let's say for the stack, we know that the most important property is last in, first out, right? So I can already specify the last in, first out property even before I implement all the features. So this is some test I can write. I say test level over here. I have some local variable stack. I simply call all the features. I have to declare their headers. I can say create s.make and s.push 2 elements, and then just go get a top, pop, and get another top. So make sure it's last in, first out. Okay, it's a very, very simple test. I wrote it even before any coding was completed for the implementation. Yeah, question?
What if one of your methods, not for this specific class, but what if one of your methods had a return function? It returns.
Well, make it just return some default value. For example, if it is supposed to return a Boolean, just return false. Supposed to return an array, just return empty array, right? Yeah. Basically, you want to just write test cases to document what exactly you expect from your class as soon as possible. Okay? Any questions about this? I'm just giving you one simple example. So test-driven development means you shouldn't only do test 5 hours before you submit your projects, right? You should do it. You should interleave the process of writing test with your writing the code. Okay, that's kind of the idea. Okay, test is an incredible tool to help you. Okay, so now let me go back to the iPad for the rest of the lecture here. So there are 3 kinds of tests we can write. Okay, the first 2 kinds are easy. I'll go through them very quickly, but the third kind needs a little bit more explanation. The first, so 3 kinds of tests. First kind is you test for normal scenario. For example, I try to withdraw some affordable positive amount from the account. So that should be a normal run. I should expect, used to be 100, after withdrawing 10, it should be 90, something like that. There's no violation of contracts expected, okay? The second kind is when me as a client pass an invalid input to the feature that I'm calling. For example, I give a negative number to withdraw. In that case, I should expect a precondition violation to occur, right? It shouldn't be a normal run. The third one is interesting. Let me mention that briefly. The third one should be, I want to test for post-condition violation, which means if somehow the supplier implements the feature wrongly, in that case, I should really expect some post-condition to be violated. Okay? For example, what if the supplier simply say, whenever you do withdraw, rather than decrements, they will do increments. In this case, I should expect some post-condition to be violated, right? Okay, so these are the 3 kinds. Let's see how we can do each one of them. Yeah. If you say boundary cases, well, it depends. Well, if you say boundary cases, if the boundaries are still within the acceptable inputs, in that case, they should be normal run, right? Yeah. Okay, let's see the first one. How you can test for success. Okay, for those of you who already went through the video, this shouldn't be too strange to you. Okay, let's just go over very quickly. Okay, you have inherit from ES test, and then for every of your test feature, it has to return a Boolean. So here's the difference between ES test and JUnits. In JUnits, if you have a test method, what does it really mean to be a success? The method has no assertion errors, or it has no unexpected exception thrown, right? In ES test, it's a little bit different, okay? It simply means, because it returns a Boolean, the final value for the result should be true. That's the difference. Once you understand the difference, you will see exactly what we're doing here. There's only one minor detail I need to mention. Okay, let's just go through that. The final value of result should be true. Should be, okay, true. Okay, we simply got an account objects, and then we always make sure you include comments, okay, to document your test. Also, we can say create an account over here, 100. And then we simply say, now, the balance should be 100, okay? I will explain this line in just a moment. That's the only part I will explain for this case, okay? And then over there, after that, we'll say withdraw $20, and then we expect it to be 80. Okay, so now remember I said the final value of the result should be true, right? So why would you think I should say check result n? Check result n is a little bit like this if you want to know about the correspondence in Java. Assert true. Result. Complete equivalence. Basically, what we're trying to do over there is to say at this intermediate points, what I just did to reassign the result to be ACC.balance equals 100 should be true. If it is not true, I will break here right away. Okay? Why do you think that's necessary? Or, let me ask another way. Okay, you want to say something? Yes. Yeah. Yeah, exactly. That's exactly right. And I'll give you one counterexample. That's exactly right. The answer was, if we didn't have this line, let's say, remove it hypothetically, then that means it doesn't matter what this value is assigned to at the intermediate points. Only the final value will matter. Yes? No, nothing to do with pre and post, no. Not really. It's simply just the intermediate checks, because for every test feature, you may want to check different things. As you can see, for the test I gave to you for lab 1, I got so many check result in, because I got so many things to check over there. I want to make sure every one of them, every intermediate one, is actually give you true result. Okay? So let me just try to prove to you it's really important to have this intermediate one. Okay? Can we just hypothetically assume the following? Okay, let's assume the following. So now, let's say the make. We have a wrong implementation, which simply do nothing. Okay? If it does nothing, hypothetically, so that means even though we say initialize Allen account with 100 balance, but at this point, ACC balance, since we said it does nothing, what would that be? 0. 0 equals 100 would be false. Okay, it will be false. However, we said we removed this one already, right? So we wouldn't be able to catch it right away. Okay, let's make another assumption. Let's make another assumption that withdraw over here also has some very funny wrong implementation. It always set the balance to be 80. Always. And in that case, ACC that withdraw 20, doesn't matter what the argument is, it will just set the balance to be 80 anyway. So now when we say final result, ACC the balance equals 80, that'll be true, wouldn't it? Yeah. So that means if we should have caught the error in the constructor in the previous checkpoint, that's the point. Question?
We don't have that. We need that, no?
Yeah, if we didn't have it, then. Huh? No. Remember over here, the second, okay, let's say without this, right? The second reassignment over here is going to give us true. Because we assume this withdraw over here, let me just see where the withdraw is. Withdraw over here, remember we assume that this withdraw here also has a wrong implementation, which always assign the balance to be 80. In that case, when we do the second reassignment over here, ACC the balance would be mistakenly reassigned to 80, right? So 80 equals 80, true, right? So that means that the test would still be considered as a pass because the final value is true, huh? Because of implementation. So the point is the intermediate check result n is really important. You want to make sure at every point of checking something to reassign the result value, you should check it right away. Okay? That's the only detail you should really pay attention to. For. No. If, let's say, we still got these two wrong implementation, but let's say we put this back. We put it back, what's going to happen? What's going to happen is, remember, we still got this wrong implementation to say it does nothing, right? Which means after calling the constructor, we are expecting the value to be 100, but ACC to the balance, since it does nothing, it will be 0. 0 equals 100 would be false, which means check false and assertion error. That means the intermediate checkpoint will give us the warning right away, rather than ignoring that. For that part, yes. Well, if you don't have that, that means it will just go through. If you say check result n, it's pretty much like a assert true, something that's false. That means the feature will fail right away. Okay?
So all of these tests themselves are essentially little bundles of multiple attempts to see if normal execution of the
Correct.
result is
Yeah, let me just repeat what you said. That's correct. That's very nice observation. Basically, this feature over here is simply just a bunch of manipulations of your objects and group them together. But sometimes, okay, you know what? If you want to go very extreme, this is what you can do. You can simply say, I have another way to do it, but I don't think you really want to, but I can just mention. You can say, for example, Boolean 1, Boolean 2, simply Boolean. Okay, over here, rather than saying result is assigned to, you can say B1 is assigned to. Right? Over here, rather than saying result is assigned to, you can say B2 is assigned to. I keep those values. And then eventually, right before the end, I can say result is assigned to B1 and B2. That's another way to do it. Yeah?
Would this still allow you to easily trace back to where something?
Okay, good question. The question was, let's say we do have the check result n. If anything goes wrong, would it be easy for us to know which assertion error occurred? The answer is yes, because when you run the, let's say this test case, now workbench, just run. If you run it, the runtime is going to break at the very first failed assertion, so you can see exactly. So you can tell you which one it failed. Yeah. Yeah, then you can look at the debugger and see which one is false. Yeah, it's different. Yeah. Okay, guys, any question about this success case? Yeah.
One quick question.
Yeah.
Your main constructor,
Yeah.
can you check that, the object creation part?
Yeah.
ECC.make.
Uh-huh.
Can you check for the make function, the constructor? Sorry. Like in this case, test case.
Well, what do you mean to check the constructor?
State of the object if it was initialized properly.
Yeah, you can definitely check the attribute value. That's what I'm doing here. Yeah. Yeah. Okay, questions before I move on to the second kind.
Oh, just really quick.
Yeah.
I think I'm missing something. If your balance,
Guys.
if your make works properly,
Mm-hmm.
and you have your intermediate check,
Yeah.
that's all good.
Mm-hmm.
But your withdraw, let's say it's still the same wrong implementation. It just does.
Well, in that case, yes. In that case, the question was, what if the make was fine? It was fine, just right implementation. So this check result n would be okay, right? But the implementation for withdraw was actually wrong. What does that mean? That means the result will be reassigned to something that's false, right? Remember what we said before? If the test case, the final value for the result is actually not true, it's considered as a failure, okay? Okay, so there are two ways to fail this. Either because the final value for result is false, or there's some intermediate checkpoint that's failed. Yeah. Yes.
So that if it fails, it means that the postcondition of the B0 was wrong.
No, B2, if B2 is false, that simply means ACC, the balance equals 80 is simply false. Nothing to do with postcondition here. We'll talk about how to test postcondition in a moment. Yes. Yeah.
Even if we don't write the account in the curly bracket.
Oh yeah, so okay, the question was, is it really necessary to write in the curly brackets over here, account? The answer is no, okay? I tell you very briefly, because the static type for ACC is account, and this curly bracket is about dynamic type, because they are the same, so you can ignore it. But we'll talk about static type, dynamic type a little bit later, okay? Okay, second kind, unless you got any more questions. Okay. Second kind. Oh, one more thing to note. A very common error is you forgot about the Boolean value. It's really important. And then agent, the way you understand this is in 2031, you talk about function pointer, right? Agent is like making a pointer to the function. Okay. Take it for granted for now. Don't have to memorize it, but we will explain how to use agent usefully later in the course. Okay. Second kind. How can I test for precondition violation? Okay. This one is really easy. Basically, still declare ACC, and then we say create account that make 100. So far, so good. And then I say I want to withdraw minus 1 million. Apparently, that's wrong, right? I'm expecting something to occur, some precondition violation. Okay, so I'm expecting that at this point over here, there should be a precondition violation occur after executing this line. One thing to note is a very common error. In this case, we don't have the Boolean return value anymore. Whenever you want to test for contract violation, the test feature must be a command, not a Boolean value like a query. This is only for testing the success case. Okay, now that's one thing to know, and this is something you can write. I think I briefly mentioned and also mentioned in the tutorial video. Add violation case with tag. So make sure you spell this exactly how it was spelled in the original precondition, right? So this is saying that we are expecting that by the end of this feature over here, a particular contract violation is going to occur with this particular tag. That's what we are saying. Okay, any question about this? Before I move to how to test postcondition, that's the interesting part, yes.
We have to assign this to result because it's not retaining.
Yeah, no, we don't have to. Oh, right, yes, absolutely, thank you. So guys, that's my bad over here. I'm gonna clarify that right away and I'll fix the slides. Of course, you cannot say result. Absolutely, good, thank you. But the source code I made available to you, actually, I don't think this is result, it's assigned to. I don't know why I put it there. Okay, any question until now? Okay, let's see how we can test postcondition. Let me talk about concept first. The coding part is very easy. So let's think in this way. The way we tested postcondition in lecture 1 or 2 is like this. I said, go to your programming editor and temporarily change the withdraw implementation. It used to be balance is assigned to balance minus amount. I said, comment that line out, and then instead do balance is assigned to balance plus amount. Just do that postcondition wrong. And then run the projects, execute the project, and then you should see the corresponding post condition, right? But this solution is maybe working, but it's not very good because you gotta remember to comment that back, right? The right implementation. Otherwise, you might just submit the wrong implementation. So that solution there is not really good. So what do we really need is a good solution. Let me tell you what the criteria is, and you can tell me what we can use to achieve that. Basically, let's say you got your account class with the correct implementation for the withdrawal, and with also the post condition there, right? I want to basically create a second version of the account, a second version, with everything basically the same. I want all the implementation to be the same, and I want the contract somehow to be the same, but I just want to add one line of wrong implementation to it. So I'm talking about lots of code reuse. So when I talk about code reuse, what kind of a construct can we use in OOP? What? 2030? Inheritance? Yeah? What does inheritance do? If I say one class inherits from another, inherits all the features from the parents, right? In IFO, since we also talk about contracts, the child class also inherits all the contracts from the parents. So that's exactly what we need, okay? Let me explain to you using a diagram and then show you the code. And you can definitely do it for your lab 1. You're also supposed to test all your post conditions, okay? So conceptually, that's what it would look like. Okay, let's see this. Let's go, first of all, we got 2 clusters. We got a test cluster, we got a model, like an implementation cluster or design cluster, okay? Let's go with the one you're familiar with. Let's say we have the account class over here, and then we have the withdrawal method feature or command. And then this is the correct implementation, doing the minus. And this is the post condition we would like to test, which is balance equals O balance minus amount. Okay, so far so good. And the way I create a bad version of that by using inheritance, so I don't have to do it manually by saying comment out the line and comment it back, is by using, oh, by the way, that's bond diagram, so you can see that over here, the red line over here means inheritance. I just create another class corresponding to this particular test. I would call it bad account withdrawal, or whatever name you like. Just name it systematically. And this bad account withdrawal is going to inherit from this account class and redefine just one feature, which is withdrawal. Okay? And for inheritance, we know that it's going to inherit all the code. And for now, I will say, as far as we're concerned, for the post condition, if you didn't say any ensure over here, that simply means this ensure will be inherited to here. It will just be inherited. It's easiest for you to think about. But later on, we'll talk about subcontracting. So there will be a little bit more complicated operation you're going to do. But for now, whenever I say inherits, if I didn't have any ensure, inherits all the post condition from the parent class. Okay? And then over here, you can see that I simply say precursor. Precursor is like a super in Java. Okay? I'm calling the parent version, which is correct. And then I'm adding something that's going to make the overall thing incorrect. What I'm doing here. The correct version in the orange says balance subtracted by amount. And then in the green wrong version, I say balance added to 2 times of the amount. What's the overall effects? Well, I'm going to add amount to the balance, right? Rather than subtract. So overall, the implementation is wrong. Okay, so far so good? So basically what we achieve over here is that's the wrong implementation. And at the same time, the post condition is inherited. Okay, let's go on. And then in your test account class or test matrix class, we just create one test case where you have to make sure you declare this particular type, local variable, let's say. So that's the bad version. That's why you see a client-supply relationship over here, right? So we are using that particular bad version we just created. There's a bad account withdrawal. Okay, so what we do over here, we say over here, create the account, and then we're trying to say withdraw $50. Okay? So which version of the withdrawal is going to be called? The top one or the bottom one? The bottom one, right? Because that's the type, right? Okay, so the bottom one is going to be called which is over here. That's the implementation that's going to be called. But what would be the postcondition to be checked against? Top one. That's inherited. So that means we are checking this wrong implementation over here against this postcondition which you think you implemented correctly. That's how you test it. Okay? Follow the idea? Okay? Any questions before I move on to IFO code? It would only take 2 minutes or so. Yeah.
Actually, I was wondering, how do you actually make that bad account withdrawal?
Oh, I'll show you the code. Yeah, yeah. So just this is more like an architecture big idea. I thought showing you this may be easier. Okay. Any question about this idea here? It's pretty much a nice architecture. If you have certain Java methods which you also expect certain exception to be thrown, you can apply exactly the same technique over here. Okay. Yes. Question before I show you the IFO code.
So for a post-condition check, in this case, you have to use it.
Okay, the question is, should you test for every postcondition? I would say even more than that. You should test for every tag of the postcondition. Every tag, T-A-G. For example, remember the account class over here. Well, let me put it here. If for your particular feature over there, you say in short, let's say we got tag 1, some postcondition here, and then tag 2, postcondition over here, you should create a separate class to test this one, create another separate class to test this one. Okay? That's kind of the thing we're expecting you to do. But understand this architecture first before you go ahead and do it. Okay? Gotta create a new class, yes. Huh? Lab 1, I would say, for me, I'm definitely going to test. This is exactly how I test your postcondition. So you can either let me test your postconditions, or you better test it before I test it. You see what I mean? You can completely ignore what I'm saying here and don't do anything. That's fine. I didn't require you to do that. Just wait for me to tell you the result, how good your postconditions are. Okay? You better do it. You better do it. Oh yeah, I would say it's okay. It's part of your project. So if you submit extra classes, that's okay. Absolutely fine. Okay. But guys, I do recommend you do at least some. Okay. Okay. Let me just take 1 more minute to show you the IFO code, and we're done. Okay. So that will be completely. You should be completely ready to do the rest for your lab 1. Let me show you the code. Just give me 1 minute. Okay. Okay. Let's see the IFO code very quickly. Okay, so this is, let me just go directly to that slides, expecting to have postcondition violation. Okay, that's a diagram we went through. Okay, over here. This is how I create the bad child class. You can see the class bad account withdraw, inherits account, redefine withdraw, right? As we understood it. And then the constructor, you're going to declare that. And also, I redefine by saying precursor amount, and the balance is assigned to balance plus 2 times amount, right? Exactly what we said before. No surprise. Okay, let's go to the next one. And explanation here, but exactly what I said when I went through the diagram. Now, this is the ES test. But I would say you can have the same ES test class. You just add different violation violation cases differently. Well, there'll be balance deducted tag we are trying to test. So it's a test withdraw postcondition violation. I'll make the source code available to you as well, so you can have a look at that. So I'm declaring bad account withdraw, and then I say create the account, and then when I do ACC that withdraw, we know that it is going to call the bad version of the withdrawal over here. And then it's going to be checked against the postcondition that's inherited from the account. Okay, any question until now? Okay, if no question, I will see you next week.